Hello students! Welcome to the second video for our lesson in quarter 3. This video is a continuation of the first one, which is about permutation. You will be seeing here examples of problems related to permutation. So as a review, last time what we have is the factorial notation, which is the number of permutations of n distinct objects taken n or all at a time is n factorial, or n permutation n equals n factorial. And we have also another one, which is permutations of n distinct objects taken r at a time, or r is less than or equal to n, is n permutation r. That is n permutation r equals n factorial all over quantity n minus r factorial. Let us have specific examples for this one. Number 1, in how many ways can 6 children be seated in a row of 6 chairs? N equals 6 taken all at a time. So therefore, we will be having 6 permutation 6 because there are 6 children and all of them will be sitting in a row of 6 chairs. So that is 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1 equals 720 ways. Meaning to say, ang 6 na mga bata na uupo sa 6 na upuan, maaayos sila sa pamamagitan ng 720 ways, or there will be 720 arrangements for 6 children who will be sitting in a row of 6 chairs. Number 2, in how many ways can 10 children be seated in a row of 6 chairs? So there will be 10 children who will be sitting in a row of 6 chairs. So here we have the value of Rn, which is 10, and R equals 6. We will be having the equation n permutation 6 equals 10 factorial over quantity 10 minus 6 factorial. That is equal to 10 factorial. 10 times 6 equals 4 factorial. And 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial all over 4 factorial. Then we have to cancel out 4 factorial, 4 factorial, then it will be equal to 151,200 ways. So that would be for n permutation 6, n permutation r, or in this problem that is 10 permutation 6, wherein we have n objects taken r at a time. So let us go to the second type, or another type of permutation, which is about distinguishable permutations. Find the permutations of the letters MOM, or M, O, M. To distinguish the two M's, we use two colors. We have the red and the blue. So this first arrangement is just the same as this one. Another MMO is just the same as MMO. And this would be also the same as this one. Pareho lang yung letters, nilagyan lang natin siya ng color to distinguish. Pero pag walang color, meaning to say, this arrangement is just the same as this one. So what does this indicate? That there are actually only 3 distinct permutations. How come? We have 3 factorial over 2 factorial. Saan nanggaling yung 3? We have 3 letters, M, O, M. over. Bakit naging 2 factorial? Dahil dalawang letter yung magkakapareho, so that is letter M. So, dalawang letter, 2 factorial. Saan nanggaling si 6? We have 3 factorial means 3 times 2 times 1. That is equal to 6. Over 2 factorial means 2 times 1 equals 2. So, 6 divided by 2 equals 3. So, there will be only 3 arrangement. Some more examples for this one. We have here 8 stars. Ilan yung kulay? 2. We have 4. 1, 2, 3, 4. So, all over 4 factorial. Ilan yung kulay green? 2. So, that is 2 factorial. And the violet is also 2. So, 2 factorial. So, meaning to say, if we are going to arrange this one, we will be having 8 factorial over 4 factorial, 2 factorial times 2 factorial. Then, we will compute it. That will be the arrangement of the different colors of stars in a row. And for these symbols, we have the hashtags, the ampersand, and the @ sign with the $sign. So, how many symbols are there? There are 11 symbols. And how many symbols are the same? We have 3 symbols which are the same. The hashtag, the @ sign, and the ampersand. So, how many hashtags? We have 4. The ampersand, we have 3. And the @ sign, we have 2. So, for this distinguishable permutation, we will be having 11 factorial all over 5 factorial and 2 factorial. So, in general, we will be having the formula, the number of distinct permutations of n objects of which n sub 1 are alike, n sub 2 are alike, and so on up to n sub k are alike is equal to n factorial all over n sub 1 factorial times n sub 2 factorial, and so on up to n sub k factorial. Another example. How many different signals, each consisting of 8 lighted color bulbs arranged vertically, can be formed from a set of 4 blue bulbs, 3 red bulbs, and a yellow bulb? So, how many bulbs are there? There are 8. There are 4 blue and 3 red and 1 yellow. So, we will have 8 factorial over 4 factorial times 3 factorial. Solving that one, you can also use your scientific calculator if you have. You will have 280 signals. And the last part, or another type, or the last type of permutation is about circular permutations. It is an arrangement of objects in a circular manner. ABC is just the same as that as another one. Okay, please take a look at the presentation. What does this indicate? Since it is a circular arrangement, fixed A and permute or arrange B and C, so we have only 2 arrangements. For example, okay, the definition of a circular permutation is: consider one object first in a fixed position and arrange the remaining n-1 objects in the remaining n-1 positions. Therefore, the number of permutations of n distinct objects arranged in a circle is quantity n-1 factorial. Example, in how many ways can 8 children stand in a circle to play a game? So we will have 8 minus 1 factorial, that is